You might think of our planet as a calm place, but Earth has a wild past that's anything but peaceful. Over billions of years, Earth has been shaped and reshaped by epic events. From fiery beginnings, when it was constantly bombarded by asteroids, to periods when the entire planet froze over in an ice shell. We've had supervolcanoes erupting, mass extinctions wiping out nearly all life, and the rise and fall of giant creatures like dinosaurs. Earth's history is a saga of survival, resilience, and transformation. A journey that turned a lifeless rock into the vibrant, life-filled world we know today. So, buckle up as we travel back in time to see just how Earth went from chaos to creation. About 4.6 billion years ago, a swirling cloud of gas and dust began to coalesce under the pull of gravity around our Sun. Over time, these materials clumped together, forming a young Earth, a fiery, unstable world in the making. At this stage, Earth was a hot, molten mass, constantly bombarded by meteors and asteroids. Each impact contributed to its growth and energy, keeping the planet in a molten, turbulent state. But even in this chaos, the building blocks of a future world were coming together. As the planet continued to form, heavy metals like iron and nickel sank toward the center, creating Earth's core. Lighter elements like silicon and oxygen rose, forming the mantle and crust. This early differentiation laid the foundation for Earth's magnetic field, which would later protect our planet from harmful solar radiation and enable the development of an atmosphere. Eventually, as Earth's surface began to cool, volcanic activity kicked in, releasing gases like water vapor, carbon dioxide, and nitrogen, gases that would one day form Earth's atmosphere. Even though this early atmosphere was toxic by today's standards, it was a crucial first step toward making Earth a habitable planet. This earliest chapter in Earth's history, known as the Hadean Eon, was named after Hades, the Greek god of the underworld. And it's easy to see why. During the Hadean, Earth was a hellish world with violent volcanic eruptions, magma oceans, and relentless meteor showers. In fact, some of these impacts were so intense they likely vaporized any water present on the surface, turning it into steam. However, each new bombardment brought more water to Earth, slowly accumulating and eventually helping to form the planet's first oceans. These extreme conditions also played a role in forming Earth's crust. As the planet cooled, a thin, fragile crust began to form on the surface. But Earth's crust was still unstable, frequently breaking apart under volcanic and tectonic forces. Even so, this was a crucial step in creating a more solid foundation, preparing Earth for the next stages of its evolution. Interestingly, some scientists believe life could have already begun forming in this period, hidden within cracks in the crust or in warm hydrothermal vents at the bottom of the ocean. If this is true, life on Earth may have started far earlier than we once thought, hinting at a remarkable resilience from the very beginning. As Earth cooled and stabilized, we entered the Archean Eon. Here, life truly began. Around 4 billion years ago, Earth's first simple life forms appeared in the form of single-celled organisms. These microorganisms were called prokaryotes, and they lived in the warm, mineral-rich oceans. These organisms didn't need oxygen to survive. In fact, oxygen would have been toxic to them. Instead, they thrived on methane and other chemicals available in their environment. During this time, Earth's atmosphere was composed mainly of gases like carbon dioxide and methane, which trapped heat and kept the planet relatively warm. But even though the climate was stable, volcanic activity remained high, shaping the land with newly formed islands and volcanic plains. One of the most incredible developments during the Archean was the appearance of cyanobacteria, simple organisms capable of photosynthesis. Unlike other organisms, cyanobacteria could harness sunlight to create energy, releasing oxygen as a byproduct. This tiny innovation would eventually transform Earth's atmosphere, but not without challenges. For millions of years, oxygen produced by cyanobacteria reacted with iron in the oceans, creating vast layers of iron oxide on the seafloor. It took millions more years for oxygen to accumulate in the atmosphere. By the end of the Archean, cyanobacteria had laid the foundation for a major shift in Earth's atmosphere. Although life remained simple, the groundwork was set for more complex organisms to develop in the future. The Proterozoic Eon marks a pivotal time in Earth's history. Known for the Great Oxidation Event, this era saw Earth's atmosphere gradually fill with oxygen. While oxygen was deadly to many early life forms, it was essential for creating the conditions that would allow more complex organisms to thrive. As oxygen levels rose, Earth's skies and oceans turned blue, signaling a major transformation. The increased oxygen also led to the formation of the ozone layer, protecting Earth from harmful solar radiation and creating a more stable climate. Life began to diversify with the appearance of eukaryotes, cells with a nucleus. These cells were more complex than prokaryotes and could perform specialized functions, setting the stage for multicellular life. During the Proterozoic, we also see the first supercontinents forming. These massive landmasses would later break apart and reform multiple times, influencing ocean currents, climate patterns, and the evolution of life. One of the most dramatic episodes was Snowball Earth, a period when Earth's surface may have been entirely frozen over. This extreme climate likely put intense pressure on life, forcing organisms to adapt and evolve. When the ice finally retreated, a wave of new life emerged, ready to take advantage of a changed, oxygen-rich world. With the arrival of the Phanerozoic Eon, Earth entered an era of vibrant life and rapid evolution. This period began with the Cambrian explosion, an event that saw a sudden burst of diversity and complexity in life forms. For the first time, ecosystems were filled with a range of species, from small marine animals to predators with specialized features. Trilobites, early sponges, and strange arthropods dominated the oceans. The Cambrian explosion was fueled by the availability of oxygen, which allowed organisms to grow larger and evolve more complex body structures. Some species developed shells, skeletons, and eyes, creating an arms race of survival strategies. This explosion of life wasn't limited to just a few species, entire ecosystems were forming, with creatures filling various ecological niches. Although the Cambrian period ended millions of years ago, the impact of this evolutionary burst is still evident today. Many of the animal body plans that evolved during this time remain present in modern animals, including us. After the Cambrian, life continued to evolve, eventually moving from water to land. Plants were among the first to make this leap, with moss-like organisms colonizing shorelines about 485 million years ago. These early plants helped create soil and stabilize the land, setting the stage for more complex land-based ecosystems. By the Devonian period, often called the Age of Fishes, marine life was thriving, with the evolution of powerful predators like the placoderms, large, armored fish. Meanwhile, some fish developed lungs and bony limbs, giving rise to the first tetrapods, or four-limbed animals, that would eventually lead to amphibians and other land-dwelling species. This transition wasn't easy. Life on land meant adapting to gravity, finding new sources of water, and protecting against harsh UV rays. But each adaptation brought new opportunities, paving the way for lush ecosystems that would thrive on land. The Carboniferous period was a time of dense forests and massive insects, with swampy environments covering much of the planet. Oxygen levels were at their highest, which allowed insects like dragonflies to grow to enormous sizes. These forests trapped carbon in their tissues, which would later become coal deposits, fueling future industrial revolutions. As the climate cooled, the Permian period saw the rise of the first mammal-like reptiles, an important evolutionary link between reptiles and mammals. But the end of the Permian brought Earth's most catastrophic extinction event, wiping out nearly 90% of species in what's known as the Great Dying. This extinction marked the end of the Paleozoic Era and set the stage for the age of dinosaurs in the next era. After the Permian extinction, Earth entered the Mesozoic Era, the age of dinosaurs. Divided into three periods, Triassic, Jurassic, and Cretaceous, this era saw the rise of dinosaurs as the dominant land animals. During the Triassic, dinosaurs were small and agile. In the Jurassic, they grew larger, with iconic species like Brachiosaurus and Allosaurus. By the Cretaceous, flowering plants and insects evolved, and dinosaurs like Tyrannosaurus rex ruled the land. But around 66 million years ago, an asteroid impact caused a mass extinction, wiping out the dinosaurs and clearing the way for mammals to rise. Though the dinosaurs' reign ended, their extinction allowed new life forms to thrive and evolve. After the dinosaurs' extinction, mammals rapidly diversified, taking over the vacant ecological niches. Early mammals were small, but over time, they grew larger and more diverse, with species like elephants and primates emerging. Around 2.5 million years ago, early humans evolved in Africa, using tools and developing social behaviors. Over time, Homo sapiens became the dominant species, spreading across the globe and transforming Earth's landscapes. Today, humans play a significant role in shaping Earth's future, but with that comes the responsibility to protect the planet for generations to come. Earth's journey is a story of resilience and transformation, from violent origins to thriving life. As we look to the future, our role is to protect this vibrant world and ensure it remains a home for future generations. If you enjoyed this journey through Earth's evolution, don't forget to like, subscribe and hit that bell. And in the meantime, don't forget to look up to the stars.